Hi, high school chemistry teachers. I'm Kendra, creator of ChemEd Solutions, and it's my mission to change the narrative of high school chemistry from yuck to yay by designing student and teacher materials that allow you to focus on what matters most, getting all your students to be confident and successful without the burden of using your personal time to do so. I support you by giving you my best proven tips vetted by thousands of students, parents, and case managers. So today's tip comes from our unit on solutions, focusing on reading the solubility curves. So solubility curves are packed with information on the solubility of numerous salts. It is important to take some time to dive into all the finer details shown on the graphs. And while discussing the graphs as a class, I suggest setting up a simple experiment to highlight the y-axis. This is something that students tend to trip up on, especially at the beginning before we spend some time looking at it. So the y-axis, as you know, is grams of solute per 100 grams of water. And students, in their fantastic ability to read detailed information, tend to miss the per 100 grams water part. So this quick demonstration can help them remember as a visual and an experience for them. So to do this, you'll need a couple of things that you easily have inside of your chemistry classroom, and if you are doing a demonstration from home, this is something that you could easily record with just different values and a salt of choice. So I used a 500 milliliter beaker, water, a scale, a stir stick, and one of the salts that I had easy access to, or that we just had a lot of. And so I first asked my students to determine the solubility of that salt at room temperature. So it's about 22-ish degrees Celsius. And so students would read their solubility curve and give me an answer. And I'd say, okay, awesome. Thanks for doing that. Let's set up your experiment to check their answer in real life. And what I would do is, instead of pouring 100 milliliters of water, as our graph would suggest, I would pour in a larger amount, such as 300 milliliters of water. And then I go ahead and I place the beaker with water on the scale. I tear it out and begin adding in my salt. And I highlight when we have added in the anticipated amount of salt, or when we've gotten pretty darn close to it. So I say, okay, we've added it in. Now, according to our chart, if we add in a little more, we're going to get that super saturated solution. What is that going to look like? It means it's not going to dissolve. Okay, so I go and add more. It's going to continue to dissolve, as it should, because I've added in more than 100 mils of water. So I'm going to keep adding, and I start to ask my students, okay, why is this happening? And you might have some start to say, oh, well, teacher, you added in way more water. Oh, is that important? Right? You kind of play that role of, I had no idea. Or you got me. But you start talking about it, and then eventually keep adding till you get that super saturated solution, and then find that point in the graph. And they're going to notice, well, that point's not on our graph. And then, well, now let's make sense of what was observed. So again, we zero in on the y-axis, and that the graph is for 100 milliliters or grams of water. And so was our experiment, what multiplier of our anticipated amount? It should be about 3. And then we can read, oh, well, if I triple that, that makes sense. The volume's getting tripled, therefore my final amount is getting tripled. So we can also continue to have students predict another volume of water for that salt, or use a different salt as well to have them do it, or you could have students do it as well. But I find that by doing this demonstration, they go, oh yeah, remember when we did that in class? It's really triple, and then that's usually enough for them. Plus, it's super quick to do. So then we'd go on and we'd say, okay, how many grams of potassium chloride would dissolve in the following volumes of water at 20 degrees Celsius? And then I'd list a couple of different volumes just to get them in the practice of multiplying the amount read for 100 mils times whatever multiplier they have. To never miss a weekly teacher toolkit tip and get access to a PDF copy of both the teacher version, which is this, it's kind of your cheat sheet, and then I have a student version as well for it. Sign up for my email newsletter at www.chemedsolutions.com/chem guide. In addition to weekly teacher toolkit tips, when you sign up, I have a few gifts just for you. It's my way to say thanks. A high school chemistry course outline, so you know exactly what needs to be taught, plus a pacing guide, so you know how long to spend on each one. A unit checklist that you can use for any unit with NGSS tied into it, and then my personal teacher planner to keep yourself organized, less stress, and enjoying life. All that, thank you for joining in, and happy sciencing!